I want to take a quick look at number 5 and 6 on the last page of your packet. These two are somewhat unique compared to the other examples that we've practiced today. Number 5 is unique because the base of the function is 1/3. So this is a decay function instead of a growth function. The basic parent function, y equals 1/3 to the x, the table will be the inverse of what you saw for y equals 3 to the x. So -2, -1, 0, 1, and 2. Anything to the 0 power, again, is 1. And then 1/3 to the first power is 1/3. And 1/3 squared is 1/9. So this is the inverse of what we saw with y equals 3 to the x, where we had -2, 1/9, -1, 1/3, 0, 1, 1, 3, and 2, 9. And so this is just going to go the opposite. This is going to become its reciprocal, and this is going to become its reciprocal. So we're going to plot those onto our graph. However, we do have a couple of transformations. So let's check out our transformations here. I lost my pen. There we go. Having some glitches with my class pad. All right, so we have this exponent with a +1. That means the graph is shifted to the left one. So I got to translate over to the left here. And then we have a +2 at the end. So that means my asymptote is going to be at +2. See if I can get that pen tiny so I can get it on this tiny graph. So there's our horizontal asymptote, y equals 2. Now I'm ready to graph. So we'll start here where the shift line and the asymptote intersect. -2, 9 will be off the graph. -1, 1, 2, 3. 0, 1, 1, 1/3, and 2, 1/9. So we don't get a big picture of what's happening here, but I can see that this is the end that's approaching the asymptote, and this end is off the graph. Like so. So let's talk about the domain for this function. See if I can scoot this just a little bit so we can see the whole thing. There we go. The domain, again, -infinity to positive. The range, the bottom of this function, is at +2, and the top goes to +infinity. The asymptote is y equals 2. The entire function, in this case, instead of increasing, it's going downhill or decreasing from -infinity to +infinity. And so I just wanted to show you that for a function that has a base value between 0 and 1, or a decay function, in other words, the graph will go downhill instead of uphill and approach the asymptote on the right-hand side of the graph. The other example that we have here is f of x equals 2 times 3 to the x. This function is going to use your basic parent function with 3 to the x, but it has a stretch by 2. So over here, with my function y equals 3 to the x, all of my y values are going to double. So we don't have any horizontal or vertical shifts, so our asymptote is going to be y equals 0. And then I can plot these points, but doubling all of the moves on the y. So from at -2, I'm going to go up 2/9, which, I mean, the graph is so small you can barely tell the difference. At -1, I'm going to go up 2/3. At 0, I'm going to go up 2 units. At 1, 1, 2, 3, 4, 5, 6, and then 2, 18 would be off of the graph. So you can see that this graph, it's basically the same general shape as a regular growth function, but it becomes steeper quicker. And that's because of the stretch on your leading coefficient. Remember that in general form, the leading coefficient also serves as your y-intercept, and in this case that is true. We had no horizontal or vertical shifts, and so the leading coefficient 2 was also our y-intercept 0, 2. The domain of this function, as usual, negative infinity to positive infinity. The range, the bottom of this graph, is at 0, and the top goes to positive infinity. And this is a growth function, and so the y values are increasing. I've included on my blog a practice assignment to prepare you for tomorrow's quiz. Please plan to print that out and work on it, and message me or email me if you have any questions. Have a great day.